Bene, ben ritrovati nel pomeriggio per un intervento molto sfizioso, nel senso che nella storia dell'informatica personale è successa una cosa importantissima di cui nessuno ha mai saputo niente. In Svizzera un gruppo di persone che girava intorno al Politecnico di Losanna in anni enormemente non sospetti ha sviluppato un'intera famiglia di sistemi, soprattutto indirizzati verso la didattica, ma non solo, con grandissima capacità di innovazione, di realizzazione anche industriale, perché sono diventati prodotti commerciali molto diffusi, in un periodo in cui appunto era ancora importante l'innovazione, c'era tanta diversità sul mercato, ci si poteva ancora permettere di sviluppare prodotti autonomi perché non bisognava essere omologati a standard anche di fatto, come è successo dopo. Questo fenomeno estremamente interessante, estremamente innovativo, però è rimasto, diciamo, sconosciuto fino adesso perché non è uscito fuori dai confini della Svizzera. E allora a parlarcene adesso è Jean-Daniel Nicoud, che è stato l'artefice di questa iniziativa, dalla quale sono nate tante altre cose, con tante anche, diciamo, contaminazioni con personaggi importanti dell'epoca, eccetera. E quindi è con piacere che lascio a lui la parola per raccontarci appunto questa storia interessante e sconosciuta che è successa a due passi da noi. Jean-Daniel.
Okay, thank you.
The floor is yours.
So, good afternoon. Most of you drop in the computer age after the 80s or 70s at least. So I thought it was interesting to understand a little bit the difficulties and what we were doing before. I was happy to follow all the link at the École Polytechnique in physics studies. I had a long course on electronic and half an hour on logic system, just showing you can do a gate with two transistors. And teaching physics and mathematics in a college, I had free time to do something with the kids. And I go back to electronic and started with relay. Nixie tube were just available. And then at the EPFL, a student friend who was doing a PhD on logic gates and building logic modules with transistors. And the project was to study calculators. It was the application for calculators. So this was what they were doing. Big modules with gates, plenty of long wires. And I have another picture, I guess. This was a calculator which was doing probably not more than 2 operations, wiring all the adders with separate flip-flop gates. Okay, so of course I was fascinated with this, and I decided to make smaller modules. Well, first there was activity with kids to do electronics, and this was a kind of electronic kit I had documented. It was very well realized by a boy. The problem is to have the contact, the wires, and you should possibly be able to put many wires in the same hole to do something complex. So this was quite fine. And then I built my own small module. Left are the EPFL module, and right are my modules. And I was really lucky, and this was what really started all my activities from that time. You see the very small transistors. By that time, they were much larger. I got 1,000 transistors like this from a Swiss company, a watchmaker company, where decided there was no market for transistors. So I got 1,000 of them. And it's great. If you have 1,000, you really can start thinking about interesting projects. And I had a very bright student. So this was a calculator I built with these modules. So below the flat part, you have the vertical small module with one flip-flop, one gate, and the wires with the principle you showed before. And that boy made a contest, and now you see well the technology. The NIM playing machine, the problem was to have enough switches. Well, it was quite a complex. It was in '68, and he won, of course, the contest. So that was the technology. We could start to make interesting logic. And the integrated circuit just came at that time. The RTL, resistor transistor, then the TTL. And of course, I jumped to that technology, and I built another calculator, which was dedicated, I was a school teacher, dedicated to calculate the note, to make the average of note the Swiss way by that time, that is by 10 plus half a note. So it was directly computing with a good keyboard, the large key for the. Okay, so this was my first product. You see Didel, if you know. I took back the name of the company 20 years later, 40 years later. Okay, so now what's inside? Nixie tube, that was the only way, TTL circuit. And I had a big problem because the Nixie drivers promised by Texas Instruments were delayed, and so I built up a module with 30 transistors, size compatible, to solve the problem. Okay, that was used in a school for 10 years. So, of course, you understand that I came back to the EPFL to make a PhD. And the PhD was on digital to binary conversion. And so I needed, I needed small, if you analyze the operation, you have elements and you can make different kind of algorithm, sequential, parallel, etc. So this was a parallel implementation of the binary to decimal conversion with the switches, binary switches, decimal display. And what I got a good mark for that PhD because of the kids. The idea was to simulate the operation with one kid who knew the rule. You look at the binary word, you look at the report, and you do the operation. And what was of special interest is, so at the left you have the kid who have selected 1111. The result in decimal is 63. And now you can ask this kid to change the binary number, and you will see the propagation delay with some error correction, which are not the usual way of error correction. Okay, so that was quite a fun. And so now I was assistant at the École Polytechnique with a professor who liked the computers, the calculators, and me too. And there were a company, Hermes Precisa, which had interest in mechanical calculators. So we started to do calculators with the components we had. So the first machine was an A4 machine. We're very proud of it, as you see, my assistant. 4 operations in '68. Then we decided to make a smaller one. We had a smaller display, put smaller keys, but the power supply was a big problem. Then we decided to make it smaller with integrated circuits. In Neuchâtel, they were able to do integrated circuit. We got the first one circuit over 6. And of course, by that time, the Japanese had came over and they were doing all the work on 3 circuits instead of our 6. So happily, we changed the direction. It was much more interesting. To build a data acquisition system, we got a contract from the World Health Acquisition to do epidemiologic data acquisition on the field and put the information on a cassette. It was a big problem to collect plenty of sheets of papers, etc. And this was really a sophisticated system because we had no computer. All this is logic with typical gates. The memory is a cassette recorder with our own board below. The keyboard was rather easy to multiplex. The card reader was the tablet was you had contact on the side, etc. And the printer is interesting. I do not want to go into detail, but you see the printer. It's a Japanese calculator. Maybe you already have a Canon calculator. We remove all the electronic, but we need to print text. If you need to print character, you need a character generator. You need a memory for this, a read-only memory. It was not available. Okay, so this was a read-only memory. Plenty of diodes, and you cannot recognize the characters because it's inverted. In electronic, we prefer to work with 0 than with 1. So the diodes are where we have zeros. Okay, so that was a really interesting project, which of course never go to the field because the reliability of this and explaining to this, but we built at least 6 of these sets under contract of the OMS, of the World Health Organization. Okay, so now it was the time of the mini-computers. And the mini-computers, PDP-8, the Nova mini-computer suddenly was much better and much interesting, so we jumped to the Data General Nova mini-computers. And that was, of course, my role was to do education of the best possible technology. I was able to buy 1, 2 the next year. This was not enough for my students. So a project was to make slave of the computer with only what a student need, which is the panel and a possibility to write a small program. So the Nova with 4K of memory was multiplexing 8 students having 256 bytes of memory. And not only they could load the program, but we had the access to several input-output devices with a serial bus we had defined. So you will see many of these logidule which I had discovered for my thesis and were perfect toy to build things. So, and to test the logic. So this is the logic of the board, which is inside the Nova emulator, Nova Sim it was named. Okay, so that's what we were playing with. This is the serial. Indeed, we defined SPI 16-bit. plus a feedback, which was very useful because sometimes the reaction time were very slow. So now, of course, when you have a mini computer, you try to have display. This was probably one of the display of the Pablo Plateau project. Plasma display, which was terribly expensive, but we were interested to study. And we had the serial communication to make things more easy. To the right, it's a stepping motor. We built many interfaces. It was a good exercises for the students to understand the logic and by that time I visited Doug Engelbart in California. I came back with a schematic of his mouse, and I built a copy of the mouse, of course, immediately, improving. He was using potentiometer, which was forcing to lift again when the pot was at the extremity. So you see there are optical encoders, the logic to go to our serial bus and connect to. So I will not tell the story, but maybe tomorrow there will be a question about this. And I was fascinating with the idea of Doug Engelbart to make an easy communication with a computer. And one of his ideas was a chord keyboard with only few keys. So with ASCII code, it's a 7-bit, or you can work with 5 bits. You have enough digits, so trying to encode, the students here was learning how to type with fewer keys. There was a special program to teach this. And now you need a keyboard, you need a printer, and this was probably the smallest printer in the world, hand-driven. You just need to put a gear to get the synchronization on some contact or LED or sensor. And we had work, you may have noticed just a few slides before, a printer with this paper, electric paper, I do not remember the name. Okay, so that was a printer, and that was the display. So this was in '72, not very performance, but the concept of having such a display. How it is built? Very simply, you just put 4 faces, a mirror with 4 faces. You slant the faces to get the lines. And of course, it was possible because this was a circuit made at the research center in Neuchâtel. It's still a famous research center, the CSEM. They were working on LED, and they made this circuit with 5 LEDs, and I heard about it, and this started the project immediately to say we could scan and show characters. So that was a funny project. And the interface was the Nova computer. The character generator was on the Nova, so the display was small, but the interface was heavy. We needed to read the information. We had the teletype, chunking the bytes. We had a faster puncher, but only one. The reader was also a big box. Donc it was a good solution to say, okay, we can print, we can punch many tape, and we have to read them with the smallest possible device and cheap device. So You just need few diodes. There's a little trick for synchronization anyway. Okay, so that was an interesting product. And by the way, it's funny because this was in 70. I heard that in 2005, that device was reinvented by the author to send cryptographic keys on piece of papers and not on any electronic communication media. You can understand the additional security it brings, but of course when you get the paper tape, you do not want to buy a big box with motors to read it. So they reinvented the trick of just pulling the tape. So there's a web page which explains this very well. Okay, so that was before the microprocessor age. So in 71, things were moving very fast because the 4004, the 8008 were announced. I had, of course, students working and going to a company to make projects with this. I was playing with my small trick with the Nova, so I was not, but it was not yet the technology I was dreaming for. But the DRAM came, and of course we needed memory. And the EEPROM, we knew the problem of making a character generator, so we were very concerned of this. So in 73, I got appointed as a professor, but it was rather unusual to have a hacker which was not looking like a traditional academic guy being professor. But what they were not pleased because I had no industrial experience. It was an École Polytechnique, so of course either you look at the publication or you look at the experience. So they say, okay, but you have to go to a company for some time. And this was, of course, something I was ready to do, interesting things. And I visited digital equipment in January and meet Gordon Bell, which was a very key person. He developed the VAX after that. He was impressed with my paper tape reader. He was impressed with several things. And so we decided in January that I would spend a few months at DEC and trying to use their technology on display, printer, floppies, etc. So it was a very good place because if you design circuit with TTL circuit, you cannot wait to buy them. You have to be able to walk to a stock room, say, I need so many of these, and digital, it was complicated to find its way to the different stock room, but okay, and I got the help of a software guy because as soon as you think about making a microcomputer, you need some software. Rick Merrill had designed a focal interpreter, something like early basic. Okay, so this was the definition of the project. And I started in April with a dream. So this was my dream, to have a personal PCS, personal computer, portable computer system, PCS. Okay, the first time I arrived in US, I recognized the kind of my home in US was to build a mock-up in foam. But of course, this was a dream. The reality was this. I needed a display. Digital was doing terminals. the screen was a little big for me, and I got a very new display from Ball Brother, but the electronic was that big board you see. This was the screen interface. And well, a few months later, Ball Brother offered also the display, but okay. So now I had Logidul. This is very, I was getting new Logidul every 3 days because I needed more. And so this was the layout for testing the scanning, the display, and starting to show not characters, but just dots. So later, sorry for the pictures, but by that time we were not, we were just, sometime later I had the keyboard, I had the processor running. The 8080 was announced in April, and when I just had started. And of course, this was the advantage for me to be in US because I was at DEC. Immediately, I was somebody more important than a small student in a Swiss university. Okay, so I've been able to build this. And this was more or less final step. You see, I was very concerned about using buses. As soon as you have a bus, you can have module and put on the bus the processor module, the memory module, and you can make changes of the module more easily because you get new memories every several months. You have to rebuild the board. Okay, and so you recognize the EEPROM. Okay, so just hesitate when. Okay, so I come back to my dream. Because now, well, just maybe a point before. The board was, I got from Rick Merrill, the cross assembler, to be able to generate code. I had a program running, but it was down after 5 minutes, 20 minutes the maximum. I spent night trying to fix it because I had to leave. And I finally learned later what was the problem. Who knows about, stupid, sometimes the words are missing for me. But the flip-flop have sometime metastable state. Who knows about metastable state here? Okay. But the problem has been solved with the 8080A. But I didn't know that the input of the data was not double synchronized. And so sometime the program was stopping. And it's okay. So I've been teaching that concept very well since then. Okay, so now I continue with my dream. So I imagine as the board were running, I have a display, but I need 2 floppies. And you can see that I saw several of these 9-inch floppy in the room. And it was impossible to hope for smaller floppy. So the smaller one came 4 years later, but the boss at DEC was saying, no, it will take 10 years. We have to live with it. So I decided that we should develop smaller floppies. And they agreed, but okay, so now this was the status, and I had to leave DEC because I had some duty of professor. Okay, well, okay, I can mention this immediately. I wanted to tell it later, but it was not working. But anyway, there was some hope to do something. I mentioned the floppy. This was a mock-up. I got a designer at DEC who built a nice mock-up. You see, I wanted a portable computer system. It was reasonably small. You see the two floppies. Naturally, you have the girls to carry it. Okay, so this was the point when I came back with a discussion that we should continue to work together. But, so I left DEC with the promise of a contract, but I was a professor. I had also to do my work as professor. I organized the first conference on microprocessors in September. I had a lot of contact with other people working on microprocessor in US, so I invited very good people. I had very good project. It was moving very fast. I got 700 participants. So, and it was also after year by year, the Euromicro conference continue to talk about microcomputers. So I went back to DEC in October to see what they really wanted. They were interested in the thinner floppies, and a professor at the EPFL got a contract to think about the motors, linear motors, and how to squeeze the head, etc. I had to propose prototype, improved prototype. So I delivered in 75 and 76, 2 Smaky 2 and 4 Smaky 4. And what happened next? Gordon Bell was busy on the VAX. Digital, I lost the contact, but my friend sent a copy of what they had built. They built a copy, a stupid copy without improvement of the Smaky 4 with my schematics. They made a model. They photographed a girl, of course. And you can find in the Computer Museum in San Francisco. It was like this several years ago. Probably it has disappeared. So, and you know the sentence of Ken Olsen, the boss of. So that was it. So there was no reason to tell about the story. It was 2 years. My first prototype, my dream was 2 years before the Apple one. But so what about DEC? I do not know, but it was when they proposed the rainbow. But apparently it was designed at DEC because you notice the floppy was rather special. Who have seen that floppy? Okay. Because the two floppy are upside down. And this was my stupid idea to save space.
You touch the mic and a noise.
Oh, sorry. Sorry. It makes a bad noise. Okay, just stupid ideas maybe used, and of course it was not a successful product. Okay. So back in Lausanne, of course, I built the Smaky 1. Smaky is for smart keyboard. I wanted a smart keyboard. What happened? Nothing bad. Ah, yes. So this was Smaky 1. Very quickly we had to go to the Smaky 2, build several. The Smaky 3, this was all with the bus and modules. One side printed circuit board were possible. Well, two side printed circuit board was possible, but no plated through, if I remember well, and no possibility to do some. So we were getting, no, it was single-sided. The idea was to say, we do a single-side printed circuit board with a power, so we get a good power distribution, and then we wire everything by hand. And it was thin, and I have no model to give you. You have to see this, but the Smaky 3 with the 6800, no future. Well, we're not interested. I have no memory. I built this system for kids. There was a strong activity of young guy doing electronic, interested in microcomputers. And of course, nobody was supplying microcomputers at a reasonable price. The Smaky was my production from a lab I couldn't sell, so I developed this board, and we built 200 for a price affordable, 300 francs or 200 francs, with the cheapest processor by that time, the Signetics 26. But if I made you a demonstration in the place where I sit, it's a modular system. It's a two-processor system, because you can remove the processor board and play yourself the processor with the switches to access the memory and read the peripherals. And maybe I have that small video.
En fait, le programme est toujours relativement simple. Et on voit maintenant, je suis en train de charger 4 images différentes d'un dauphin dans différentes positions. Et il faut que je démarre l'exécution du programme. Et voilà. Alors, vous voyez, c'est une combinaison du programme précédent avec 4 images.
Okay, should be finished. Well, kids were doing this kind of program. I tried to show you the difficulty we had and what we had to invent to be efficient. And communication, by that time, RS-232 was something very complex, big connectors, etc. So we took the idea of the serial link, but with the clock coming back. So we did not need a precise clock, because the guy who received the information was providing the clock. If he was not able to receive any more, he was stopping the clock. So it costed one more wires, but it was much more efficient. I tried to make it a IEEE standard, but it didn't work in '84. Okay, so this is the Smaky 4. So we built 20 of them, which were wired before. The picture to the left, the right corner is not very good, but you can see the strip which conduct the wires, and somebody was dictating and going from one place to one place with a pen, and it was quite efficient and flexible but you had to be careful. You recognize the 8080 and the serial communication to the reader and memories. So the 20 was used 2 by processor, which Well, the interest by that time was not to have a microcontroller, but to have a screen with graphic possibilities. And people were interested to connect that terminal more powerful than the existing DEC terminal, which is only alphanumeric, to start developing more interesting software for education or else. Okay, so this was the package of the Smaky 4. We tested, of course, telephone communication. There's no disk, so you have to download the program with a paper tape every time. But you notice the 2 cassettes on the side. So everybody who has been using music cassette knows that it's not reliable, you cannot work with this. Our solution was to say, we have to simplify the mechanics. We have 2 motors. One motor moves the tape in front of a reading head. One motor moves the tape in front of a writing head, so you can copy. And you have a third position, which is directly on the motor for rewind. So you can get a quick rewind. No mechanic complexity. The interface on the top right shows that you have to work with the size of pulses and be sure that they are well separated, even with the random speed of the motors. Okay, so that was something which has been put into production on a product I will not speak about. And of course, now if you have many devices, you need a network. So we designed the Cobus network, which was not so much electronic. There was an interesting project at Palo Alto, and so a coax cable. The problem of network like this is the collision. So I will not explain in detail, but you can understand that there should be you can have 2 people trying to access simultaneously. So depending on the length of the cable, you need to have a mechanism that detects the collision and give the priority to one of the devices. But you cannot do this only on one pulse. You do it on several pulses, and the logic related is rather simple. So with several pulses here, you define the priority. And when you know that you have one-to-one communication, you can increase the speed. So by that time, the speed was maybe 100 kilobits per second. Kilobit, not byte. So we were quite pleased on this, because again, I had many students. I wanted to have many posts, and the Nova had been improved with a 60 megabyte disk, and was used as a server for the network of 20 Smaky. Not so many, well, of the 20 Smaky, 6, because every 2 days or 1 day we had to build a new generation with new memories. So the Smaky 6 was developed for my lab with a network, with projects where I do not know what we were doing here. It was a funny picture with the different screen size and trying probably communication between on the network. So this was the Smaky 6, which was not a product. It was a production of my lab. I had 2 technicians. It was really a great place, which now you will heard about the École Polytechnique because it's 50 years since it had been a federal school, and I didn't mention it, but I have been appointed as a professor because they needed professor to grow after the sudden wish to be a big federal École Polytechnique. And it became very, very big. Okay, so this was a Smaky from the lab. This was my personal Smaky 6, of course. I could carry when I took the plane and show that I was able to type on a keyboard, but not communicate. Well, okay, that's the story. And I got the request of a teacher in Geneva who wanted 6 Smaky 6 to be used as terminal on the NORSC mini computer he had, so he needed many terminals with graphic possibilities. So a student built the company and started the production. My wife who helped for the administration. The company, the student was not good enough, so my wife took the control and built 4,000 Smaky. So 300 of this one, and I will show you the Smaky family, but what was interesting by that time for me was to follow the evolution of the components. So I would like very much to explain you the wonderful change between the 8080 and the Z80, then from the Z80 to the 68000, then the 68020 was also something very interesting. And then the video RAM were also the device which suddenly allowed to have big display and of course I could get these components as easily as Apple computers. And for 15 years I built exactly this, well, not exactly, but the equivalent machine than Apple, producing the company Epsitech. I was made the board in my lab, then Epsitech was doing the production, coming to the market at the same time because we were a small company. Apple had to build, to plan for big quantities and etc. And the software, it's incredible, but I had few guys who was doing the same software, fulfilling our needs, which were the same, to have a text editor, to have a tabler, to have a text formatter for the laser printer, etc. So we are not reinvented, but we did it our own way. And the total was 4,000 Smaky built. And what is, of course, extraordinary is it has been built by a small team. And of course, people ask, but why you didn't make a product, why you didn't sell? The situation is the French part of Switzerland is 1 million person. On one side, you have the German-speaking Swiss. You have to translate everything. They have a different mind. On another side, you have the Italian-speaking and the Italy. It's also a lot of difficulty. On the French side, they have their own way of doing, and they were working on their computer, microcomputer programs, so there was no hope. So if you make a calculation, I never did the ratio, but I guess that the percentage of computer we had per person was much better than in US and maybe even in California. And if you take the percentage of this computer in school, because the market of EPSITEC was more than 50% schools, this was really quite impact. Okay, so you want to see a few machines. This was the Smaky 8. The Smaky 8 was like the Visa, the first 68,000 machine with a better screen, with an operating system, which was not a CPM copy, but by the way, a student of, the year he was starting the university in his holiday, he designed the operating system, which will never change. And other manufacturers change their operating system frequently, as you know. The Smaky 8, yes, I have time to talk about this, was used by the CNET, the France research company, for an exhibition in '84. They had the Minitel, which was for transferring alphanumeric communications. And they was interested to understand the problem of transferring images. And the Smaky 8 was apparently a machine with a good enough screen, a graphic screen. And what is fun, and that's why I tell this, is the communication of images between two distant machines. They needed two modems at 300 baud. So that was the best that was possible by that time. By the CNET was a better research company defining the protocol of communication with Pouzin, etc. Okay, so you know the problem with the Lisa. It was not a successful product. It was replaced by the Macintosh. So we designed the Smaky 100, which was really the equivalent of the Macintosh, and the same software came on. Then there were some people who wanted to have colors, so we made, I made the board, but then I was not concerned about the box, and the Smaky 300. But the Smaky 300 was interesting because it was the first Smaky smart keyboard. You see, I made a narrow board which could fit in the increased thickness of the keyboard. And it was a Smaky with the plugs behind. So this was the Smaky 332 with video RAM. And this video RAM allowed to have big screen, and even we had two screens, which appeared to be very useful because one of the screen was to control the laser printer. So we bought mechanics of laser printer. They just have a video input plus few control signals. So we were not afraid about going in any direction, and the book you may have seen of my booth have been printed at home with such a machine as a video controller. Okay, so the look of the machine, which was sold by EPSITEC, was quite nice. And this was a cheaper version for schools with the 6820. And that was my last machine, because by that time, the cost of the components we had to pay for building this machine was starting to be the same as the cost of a complete finished machine. So there was no hope to compete. But of course, we had customers with the software. They wanted to continue with our software. So the question was, do we put a Smaky card inside a PC, or do we put a PC card inside a Smaky so we can use the internet was a big problem, because the team was too small to support internet. So a very bright student built Smaky 400, which is 6840 microprocessor inside the PC, but 200 have been built and sold and working. And now what he made, which was better, was an emulation of the Smaky software. Because the processor, first, you need at least 20 instructions of any processor to emulate 68,000 instructions. But since the processors are 20 times faster, you can get on your PC a working Smaky, running the software which have been written in 85, and I know people who are doing this with the students. You have the green screen people like very much because it's old-fashioned. Okay, so that's life, and you can get it freely on internet, of course. Okay, so that's the end of the story. Thank you for your attention.
Thank you. Se ci sono domande? No question? Una. E forse serve il microfono volante che però scrocchia un po'.
About the Smaky with the vertical monitor.
Yes.
Did it have a graphical interface and mouse?
Well, with the mouse on all machine, of course.
And a graphical interface like the Macintosh? Windows.
Yes, exactly.
And last question, did it even came out of Switzerland, other markets?
If it was sold?
Was sold, yes, out of Switzerland.
Well, we were ready to accept. There's been few outside Switzerland, but you could get other machine with a better. We're not writing we're not making any publicity.
Yes, I'm asking because I
machine.
saw something similar in Italy once in the period, that period. It may be possible that one of those came to Italy.
Well, I had very good friends at Politecnico Torino, so I'm sure they got several Smaky with exchange of students and.
Thank you. Thank you.
Well, one thing I didn't mention, but I still have on my old desk a Smaky running with a big screen. I switched off the screen because it had to change 10 years ago. But the computer is running all the year with a set of 3 software I still use from time to time. There's a text editor. Well, I do not use a text editor, but there's a list of all my old friends, the list of address of all the conferences I've organized, etc. And there's a drawing editor which was made specially for me. I was asking, add that function, and so it's so comfortable that I still continue to use it and put the information on the diskette, go to my PC to read it. Okay, so that's funny, but there's a disk. It's running for 30 years. I never switch off. Frequently, it's when you switch on and off that you get problem. Well, it has a problem once a year in June because I forget to remove the cover. There's no fan inside. So when it gets too hot, I have to remove the cover and restart it. That's amazing, but unusual. Okay, sorry for your question.
You showed a Smaky model with a strange floppy.
Sorry?
You showed before a Smaky model with a strange floppy. What were the differences between that floppy and other floppy models?
What do you mean by Smaky model?
There was a Smaky computer before. You showed a picture of a Smaky computer that had different floppies that you said was later abandoned.
The floppy that you...
The floppy I designed at DEC.
Yeah, sorry.
I got the contact.
No, what
we got a contract to study some mechanical part of that floppy for moving the head. We made a report about using a stepping motor, a linear stepping motor, and we never heard about it. So apparently I do not know the... I was busy with my Smaky. They were not soliciting me anymore. I had no reason to go there and ask questions.
Thank you.
That's a pity, but okay, it happened like this. Project fails.
Altre domande? Ok, allora grazie. Thank you. Very interesting presentation. Thank you very much.